So in some previous videos, we looked into the Hyper-Tough tools. We looked into the 3/8 ratchet. We also looked into the 3/8 impact wrench. We went all the way to 250 foot-pounds, and it was successful of removing the bolt torque to 250 foot-pounds. However, we did use a modified pack. So in the previous video, we also looked into the 2 amp hour battery. We looked into how it had the battery charging port built in for the very low current charger. We also looked at the plus and minus terminals and the ID and the C minus terminal. We took a few minutes to compare it to a M12 battery, which, as one viewer pointed out, this is an earlier Milwaukee battery. Some of the newer or later gen M12s do not have those tabs. These are genuine Milwaukee, they're just older packs. My 2.0 and higher M12s do not have these tabs. And I also wanted to share how the older Craftsman Nextech 12 volt series seem to have a very similar mold for its batteries, and it's unmistakable how close these are. Now, they're not compatible with each other, but they are extremely close in the mold for the slide of these batteries. We briefly discussed what we found inside of the original 2 amp hour battery. We looked at the board and we looked at some of the MOSFETs on the board. We had a 30 volt 10 amp N-channel MOSFET. We also had two 100 amp or 70 amp continuous MOSFETs for the output control of the battery. As you can see here, it's going from the minus of the cells itself coming up and going out through the MOSFETs through what they're calling, it looks like the P minus terminal. We also looked at the cells in these batteries, and they're KAN, K-A-N, definitely 18650s, 2000 milliamp hours, and B3C24, which I couldn't find any information on. So today we're going to start off really quick here, just getting into a 1.5 amp hour battery. Probably very similar cells, just 1500 milliamp hours, but I'm assuming the board's the same. And we're going to show in this video how we modded the pack with 2800 milliamp hour Molicel 18650s. So we're going to be careful here and take off the NTC like so. Just make sure we're cutting on the silicone and not the thermistor itself. So I do want to take time here to mention lithium battery safety. I do have a video called Lithium Battery FAQ number 1 that I talk a lot about safety and where I get my cells from and a lot about how I handle them. And overall, just lithium battery safety. I highly recommend watching that video if you're not familiar. And this video is just for looking deeper into how I modified these to be higher output. It's definitely not something you should do yourself if you're not qualified to do so. Just remember, lithium batteries can be dangerous, just like gasoline or anything else. There's a lot of dangers involved. Just need to know what you're doing. We're going to put on some flux. I'm going to use some low melt solder here. Just going to work this low melt solder in so the melting point will be lowered. I'm just going to take some braid here and come across, and we do have to be careful where we touch with the copper braid, but here on the minus terminal, this is where it goes through the MOSFETs and out to the minus terminal on the battery. So it's okay if it touches right in here. If not, then I wouldn't allow it to touch, but you do have to be very careful on some of the other terminals, as we'll show. We see the rosin flux starting to pour out of our braid here, but there we go. We got most of that. We do have to be very careful with this B1 and this B2 solder joint. This is for our cell monitoring, and it's very close to the others, and this is a potential of a cell from here to P minus, and of course from B1 to B2. So you gotta be very careful here. So I'm just gonna suck some of it off, and then with the low melt solder it does help just pull that out. Going to go ahead and get the plus side where our wire comes up for our P plus. Now all this is together here on this side like so as well, so it's fine. Suck what we can off and then heat it up, and this low melt solder should allow it to just easily pull out. It also stays liquid for a few seconds there to give us something easier to work with. Now this B2 terminal is probably the most tricky. I'm going to put some low melt solder on here maybe a couple times to work it in really well. I'm probably going to attempt here just to liquefy it and just pull it off when I'm ready. I can push up. Well, this foam adhesive is holding me here on the board, but these tabs are giving me some flex here. Good that they give you some room to be able to pull up on that. Make sure our thermistor is not connected anywhere. We do see some components on the bottom of the board already. Let's go ahead and pull up on these tabs a little, and I'm going to heat it up, and it should slide right off. And there's also another way I'll show here to do this. I did this on the second one I done. I like to sometimes take my curved soldering iron, and if you see here, you can just roll up this braid and just curve it back to you, and that way that braid won't come across to the right or left on anything. You just have to be very careful with that one, but either way you want to do it's fine. They both work well for me. And our board's off. Quite a complicated design to be just a 3S 1P pack, really. A lot of work goes into this board. We see our components here a little bit better. Just show it here before we clean it up. We see the MOSFETs as mentioned, and we also have a 104 resistor up here that's going to our ID, our little ID terminal, and that is a 100K. So it looks like that 100K resistor back to the negative is something to do with the ID here. I'm not real sure. I hadn't really looked into it that much. So on the back side, we do see another of the AP4406B. This is another 10 amp N-channel MOSFET. We also have two more 8-pin chips on the board, and they are not MOSFETs. They don't have like their four legs going out like they're all together like a power device. And I really could not find anything on these, but finally, with some AI search help, the 1035AL did show on AliExpress if you buy them as a lot. They seem to talk about it being a voltage regulated chip. And then the other AI photo that popped up was on AliExpress as well. And surprisingly, it's a 3S 12 volt little board that's very, very similar. And if you zoom in on that picture, sure enough, it is a 1035AL chip on that board as well. So not much help, but just throwing out that little bit of research there. Going to take time here in the wick and getting this low melt solder off and cleaning it up a little bit. It really is easy with this low melt solder, but we just got to make sure we get it all off. Obviously, it'll make a bad solder joint for us going back. It'll be more brittle and of course lower in temperature as well. Bring out the 99% alcohol. We'll fast forward through a lot of this, just going to clean the board off. A lot of the flux residue and just make sure all the holes are clean, because any prep here is going to help tremendously putting it back together. Back with the pack, go ahead and take off this little card paper insulator. We see we also have a plastic insulator. We're going to have to take this strip off first. Now I do try to use plastic tools as far as I can, but honestly when it comes down to these strips, I just have to use metal tools sometimes. Just being very, very careful, especially on the positive side of the cells, as we've discussed many times here on the channel. The negative side I'm not quite as worried about. The positive side, you definitely don't want to pry towards the edge or rim of the cell. Of course, that's negative potential. As long as we have that plastic ring, I'm not too worried about it. I'm going to try to be careful here and pull these strips off the best I can, because I do want to save as much of them as possible. I don't have to reuse all the strips, but the ones with the tabs coming up and already formed to go through the board to be soldered in, I'd rather reuse that part for sure. Save a lot of time. Straighten it up with my flat nose pliers. I still got to get this one off here where it comes through on the board. This is on the negative side. I'm just going to rock it back and forth. I'm going to peel off this little card paper cell insulator. Sometimes these peel off and you can reuse them, but if not, I do have some new double insulators. This bottom is not going to be able to be saved here. We got foam on top of the paper, so it's going to pull off. And then of course the strip was in between the paper and the foam, so go ahead and get our positive connection off here where it goes up to the board. Just going to separate these using a little plastic pry bar. And on this one I'm just going to rock it back and forth and pull it. And here's our new Molicel cells from 18650batterystore.com. As mentioned before, I just like to get a lot of my cells from them. They usually have a lot in stock and they ship really quick, so no sponsorship there. Just I get asked a lot and I always give an honest answer. That's where I get a lot of mine from. I don't necessarily trust what I see on Amazon or eBay for sales. I've never had a problem myself personally with 18650batterystore.com. I'm going to take some of these double cell insulators and put across like so, paying attention how I'm putting them, so when I put my other one across, I'm actually adding a double layer between my plus and my minus. And I always take pictures of what it looked like beforehand. And it never hurts to go ahead and take your 3 cells and put the configuration together before you start taking it apart. I did have one put aside that I did like so. I'm going to take this little paper insulator and transfer it to the new pack. That's where the positive strip comes around the edge of the cell, so we definitely want protection there. I'm going to add a piece of Kapton tape as well. I'm going to bring over my cheap spot welder. This spot welder does very well for the money. I'll show a picture of it up here on the screen. It's held up very well. I do get asked a few questions about it, and it's relatively cheap. I just use it with this LiPo pack, and it's got a lot of flexibility in how you use it and what you use it with. You just do your settings. Well, first we hold a button down to power it on. This is in between a 5 and 10 amp hour. We select that. It's a 50C rating, so we go all the way to the top. I'm going to go all the way up on the output level. Depending on what battery you put on this, a hot enough battery, it actually will not allow you to go all the way to the highest output level. Just going to start building the pack now and spot welding these tabs, and I'll look back at a reference like a photo of the one before as needed. Once you get used to building battery packs, they're all pretty similar. You're usually going to alternate plus and minus, obviously, and the way your balance leads come off is usually pretty similar. It is a little more in depth doing these battery packs, and the 2P pack is a lot more to it, as you'll see later in the video. But some questions you get asked sometimes is, why not have longer leads so the board's not kind of moving around at your hands? Well, the heaviest gauge and the shortest leads possible is the best for your spot welds. And the reason I don't have this in a case, they heat very quickly. A lot of current's pulsing through and they do get a lot of heat. So I'd rather it be open. I do have some tape over the main part of the plus and minus terminal so it don't easily touch something. But other than that, I just try to be careful with it and use it like it is. So that's one side about done. I do have to put the white balance lead up for the B1 terminal. I'm going to put some foam on this one. On one battery pack I didn't put foam, and then one I did. My foam was just a little bit thicker than the factory foam, so it makes it a little bit harder to push and put the pack back together, but it's worth it to have that protection really. I did cut out a bottom piece of new foam as well, just to give those 3 some padding on the bottom. Now for the other side of the pack, I'm going to reuse this red paper insulator. It's in really good condition from the original. Get the right orientation on our plastic insulator, and it goes like so. And our thermistor will go out the back. Going to go ahead and put a new strip on here from plus to minus. Fast forwarding through a lot of this so it doesn't take so long on video, but I hope you can still tell just how good a job this spot welder does for the price. I decided to use a new strip here and just take this piece and tack it on top. That's where I got a solder on, and it saved me a lot of time from trying to cut that out as an exact replacement. This new strip on these new cells, it spot welds beautifully. And this spot welder actually does a pretty good job of putting the old ones back on. As long as I flatten them out really well with my pliers. It might not look the prettiest, but it does tack them on there pretty good. Straighten this up, and there we go. I have to put the strip with a tab on it on this side. We'll put our paper insulator back on. I'm looking to see the best route for this positive wire going back up to the board. It will reach, but it might make it hard to get the board on. So I might take it off and solder it and just remove the wire from the bottom like so. I'm going to try to go ahead and just attach the wire. I'm just going to barely tack it on here for now and clean it up later, as I might have to adjust it. Then we'll take our B1, which is the white wire, and we'll push it through. A little bit tough to get in there, but we can wiggle it up through there. Let's put some flux on here and let's solder up the B2 tab and the B1 wire, and also our main negative tab that we spot welded on there. And there we go, that looks good. Hit the B2 tab just a little bit more there, and we'll go ahead and touch up the plus. I'm going to push up on the wire with my thumb and just push it all the way up, and there we go. Move the microscope out of the way, put some Kapton tape around here, and I'm just going to solder this red wire back on the tab at the bottom. I do want to take the 99% isopropyl alcohol and clean up the flux from the board. I typically only use 91% or higher and like to use 99% when the board is live like this. It actually has the cell voltage on it. Definitely cannot use 70%. Too much water in it. We're not fully charged, so we check our voltage across the whole pack here, 10.6 volts. So somewhere around 3.5 per cell. Our B1 to B2, yep, right at 3.5. Our minus back to B1, yep, around 3.5. Awesome. We also see here we go from our C minus terminal, checking our thermistor back to the positive. We do read voltage, making sure that circuit's still there. One more round of Kapton tape. And these battery packs look a little bit different from frame to frame. I did do 2 separate packs and I did video both. I videoed some parts of one and some parts of the other, so it's kind of put together. They may look slightly different, but the same techniques were used. Going to go ahead and put our top cap back on. That fits well. We'll slide it into the bottom of the housing. Make sure our latches catch. Awesome. Yep, we get our voltage here. We're going to go ahead and put it on charge. Got one battery fully charged here. Take it out. We'll come back when this one's charged up. Fully charged. Now I'm going to put a sticker on here to show that this is now a 2.8 amp hour and up to 35 amp cells. While charging, we still at around 33 watts, so we're not overdoing it with the charger. The 2 amp hour is showing right at 32 watts or so, so very similar, so not worried about that. Come over and check, and right at 12.6 volts. So I use this 2.8 amp hour in the 3/8 ratchet video to see if we can make it do a little better. And it did seem to perform better with this higher output battery. I also wanted to show here what we could do with the original cells because there's nothing wrong with them, so I'm charging them back up here. I had depleted the battery before I started working on it for safety reasons, but now I'm fully charging them back up. And we can use these in other things, like this is just one example here, but we can put in a flashlight like this one that is from 18650batterystore.com. And there's a lot of 18650 gadgets like power banks and flashlights, and make use of these batteries that's otherwise good cells. So that's one reason I keep a lot of cells around also. Now in this part of the video, we're going to look into the 4 amp hour battery. I also put the same cells in this one as well, but this was a very time consuming and in-depth battery rebuild But I thought it would be very handy to try this with the Impact, and it seemed to perform better for sure. We still didn't quite topple the Milwaukee with a 2 amp hour battery, but it still was right there with it, which was pretty impressive. But I do want to show the similarities and the differences here, and I won't go over the similarities with the 1P pack that we just built from the 1.5 amp hour, but we will build on that and show the differences in this pack being 2P on this 4 amp hour. Of course, 2P meaning the parallel cell, so we got 2 sets. Just like we have on top here was the 1P, and then they added the other 3 on the bottom. All these are 2000 milliamp hour to give a total of 4000 milliamp hours or 4 amp hours. But one thing that's very interesting here is the board is not exactly the same, but similar. And we have a sleeve in between here that we're going to have to take off afterwards and make sure we slide it back on before reassembling between the top and bottom boards. I'm going to go ahead and peel off a lot of these nickel strips to save some time, and we are stuck here. We definitely have the foam here. I'm going to pull this foam off, and it's actually coming off well enough to reuse it. It don't break as easy as that thinner foam on the other pack, but it's also some silicone in here, probably from the NTC or thermistor for the temperature sensing. I'm just going to carefully pry these out, and there we go. As we suspected, it's got that white silicone in there. Going to go ahead and pull the cells from the strips from this side. Just rock this one back and forth. This is on a positive side. Gonna be careful with this positive side here. Try to use the plastic tool the best I can and just pry off. And as mentioned before, on the positive side, we do have an insulator here around the ring, the white ring on the inside. But of course, this outer rim is all the negative side, so we definitely don't want to come across or pierce into that insulation. So that's our temperature sensor and what it looks like. I'm going to go ahead and flatten out a lot of these strips with my flat needle nose pliers. So as we look here, we have 2 tabs, 3 wires, and also black and white wire that goes up to our other battery terminals, the C- and the ID. So it's 5 wires and 2 strip tabs that we have to desolder. And just to show here, we're right at 10 K ohms at room temperature on that NTC. Just if you're curious about that thermistor and if it's a typical type, and it seems to be. After desoldering these tabs and wires, we're off like so. I still got to remove the black and the white wire that goes to those terminals. Just trying to see here where's the best way to do it, and it looks like also from the main board, because I do have some slack here. Just want to be careful and let no wires touch. These cells are still together in a 12-volt configuration. So very similar to the 1P pack in the first part of the video, I have reassembled this pack here that might look very familiar to you from the last pack. All this part right here is pretty similar. The difference is this wire goes through the center, and then of course we got the C- and our ID wires coming up, white and black respectively. And then we have a black and a red wire coming up that are both current carrying wires for your power side, not just for monitoring on those. I'm going to go ahead and solder the tabs back on this top board, and we'll slide this sleeve on before we forget. Just making sure nothing touches here. I just use the wires memory to my advantage in the corners, but we could always put Kapton tape on there. We didn't feel good about where they was actually touching at. This bottom also had that spacer with the wire barely sticking out, so we're going to have to line that up. By the way, I have already soldered the black and white wire back on the board here, and then I can lay this over and try to get my other 3 to line up. The middle one actually went in pretty much non-issue. The black wire was a little bit tough, and then this red wire is being really tough. I got it started with my fine needle nose, and I had to take the finest screwdriver that I have, a little jeweler's screwdriver, and push some of the strands of the wire through the hole. It's fully cleaned out, but it was still very tough to get that wire in there kind of at an angle. And I didn't let the board back off of the other 2 that actually already through their plated through hole. I'm just going to use the pliers to pull up on these all the way. Go ahead and put some solder on all 3 of the wires and both of these tabs. And here we go, finishing up one of the large tabs, and we'll be done. I'm going to give this board a good cleaning with high percentage alcohol. And then we can put our plastic cell holder on here. Make sure our NTC is pushed against the side so it can pick up well. Orient our cells in here correctly, and then make sure we turn the cell information so we can see it. I'm going to go ahead and put a dual paper insulator on here between this plus and minus. And we'll push these tabs down and spot weld these really quick. So after the spot welds, I want to show here, I also went back and added some extra wire here. This is Teflon coated wire, so it'll handle a lot of current for its size. The black wire, I'm going up to the negative terminal and coming down. And notice here that I took time to pull up a little solder on that MOSFET tab and connected it there, because of course the MOSFET goes down to the negative terminal of the battery. So that MOSFET should be feeding all of our negative up to our negative output tab, or P minus. And likewise, on the positive side, we do have a smaller red Teflon wire that I soldered up top and just worked my way through this sleeve, and I was able to take it all the way to the plus terminal and solder it there. It just goes straight to the plus on the cell. Go ahead and put our battery case back together. All this really went together better than I thought it would, but it was still a lot of work and absolutely not worth your time and money for sales to fix a $25 battery. So hopefully you viewers watching just know that I showed that to beef up that battery pack just simply for this testing to see how far it could go, or if battery packs would even help the tools at all, just out of curiosity. You know, for a little bit of science and a lot of fun. So just enjoyed it, playing around with it, seeing how the batteries are made. I will say I was very impressed with the build of the battery, and I'm absolutely fascinated that they can build that pack for $25. The cells are not the highest output, but I tested them in the very first video, the one with the 3/8 ratchet testing, and I couldn't believe it, but they were actually spot on with the capacity that they rated them at. So no gimmicks there, but I'm sure they did have to skimp on the output of the cell. I think the 2.0 pack says on there that it's a 16 amp continuous output. So that lets you know those cells are just a little less than half of the output that the Molicel 35 amp 2800 milliamp hour cells are. But a few viewers did mention they wanted to see how the pack build went and what all it did take to build that pack. So there is a summary of both of them, and hope you enjoy the video looking into these Hypertough packs. I have a link down in the video description for a lot of the tools and items I used here on the workbench today. A lot of those links are affiliate links, and any of those links you click on help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.